皆さん、こんにちは。来台湾のジェンルリンです。ありがとうございます。So the topic today is about speed up iOS development with LLDB code injection and framework live preview. Okay, so a general development flow looks like this. So start from some specifications, and then we do some developments, and then we ship out the final products. And in detail, the developments including build your code into executable binary, and then we run the code, and then we do some verifications using UI test and unit test. And then since the cycle, so it happens so many times, and then we often have a pain points that we have a long build time issues. So especially when in big project like Line, so you have to build like for more than 10, more than 20 or more, or even more. So how do we deal with this? And my colleagues at main session and later we'll have a short talk by T-san. They will introduce about Bazel to further reduce the build times. But for people who are seeking for an easy workaround, then we can try this methodology. So the main methodology is to just reduce the number of times to rebuild the whole app. And then because we don't need to build every line of code, because if you build all of the line of code and then build all the modules that you don't need right now, it will take a lot of times. And then usually people are just working on small views and small modules or small presenters, and then you could just build that presenters to reduce the number of times to rebuild the whole app. So first, we could build only at the framework level. We could build only the module that you're currently working on, build the code that you just need. So for example, a normal app architecture will look like this. So you have several features A, B, C. Features might be like you have a profile page, you have an edit profile page, and then you will have a setting page, or even chat room or friend list. And then you will have to call API, so you have network modules. And also you have to do analysis, so you have tracking handlers, you have database managers. And then each features will be related to each other, and it will have dependencies. You might present a profile edit page from profile page. And then every page has to do analysis, so you have to call network module and tracking handlers in every modules. So by cut down the dependencies between coordinate pattern using different coordinate patterns, and then we could cut down the dependencies between features. So you don't need to put the dependencies between features. And then using the technique of dependency injection, so using the mark technique and mark and stop, then we can cut down the dependencies between features and modules. So in this way, we could have less compile source count, and then we could have less build time. So in our experience, that previously like project will be depends on which computer that you are using. So probably they will be more than 20 or more, 20 minutes or more. But by doing this, we could reduce the build time from that amount of time into several seconds, because we're only working on some small part, usually. And then tips for existing projects. So because clean refactoring and then clean architecture is so difficult, and then you might need lots of changing of your code. But actually, we could start from something small. So I think apply some dummy framework is an easy step to do, because usually when you're working on a view only or a controller only, we could put it into a dummy framework. And then this dummy framework is not embedded nor not linked by other targets. So it appears in both targets of your normal app and this dummy framework. And then in this way, this small project does not affect the original function. So it's easier to apply, and then it's easier, and we can refactor afterwards just by building this small dummy framework. And then if we build at framework level, it will be faster. And then how do we verify that view has been implemented correctly? So we could use SwiftUI and Playground live preview. SwiftUI has been released this year and so popular, and we could help you use its features. Like so, it has interactive features. We could preview in different view state by clicking or scroll that view that you are building. For example, like you could like and unlike that view inside the preview to view the other view state. And also, it has fast access features. So in order to render that view, we no longer need to scroll a lot of pages and then click the buttons in order to just render that view. We could render it directly. And then we could preview it in different environments. We no longer need to go to general settings, general, and change the language and change the regions. We could preview that languages, different language, say Japanese or English, on the fly, in place, and with different device sizes. It could save you a lot of time. And then how do we verify the logic at framework level? Okay, so usually we use, instead of manual testing, besides manual testing, we usually often use unit tests and TDD, test-driven developments. And then start from some small failing test, and we will just write the test, but without any implementations. We do minimum of the coding to make that test pass. And after that, we do the refactor later. And this is a cycle, and then it happens so many times. So if you want to practice TDD, that means that we have to make the build time fast, or otherwise we'll end up have slow speed of development. So to build faster at each iterations, we could unit test that framework in Playground for interactive environments, because Playground has it could run the code line by line, and it can display the variable result in line. So it's better, and it's recommended to use TDD in Playgrounds. And we could move to test target for CI after compilation. And then after all the modules has been done, and then we still have to verify it with the whole app level. So how do we speed up this whole app verifications? So here's the main philosophy, that we have to reduce the number of times. So at least we have to build once to see the whole app integrations. But we could use LLDB to modify control flow without rebuild. If you want to see other results, and if you want to see other case in the switch cases, we could use LLDB and then inject new code to it. So we just need to build once, and we can see different results. So for example, I have a little example right here. This is the empty function called deep-tab downloads. The goal is to download this string from server, and then save it into these README variables. We don't want to rebuild the whole app, but how do we do that? So we could insert a breakpoint and then enter LLDB mode, and then type some expression. And so here is a simple it works. Then enter this multi-line environment, and then we could copy and paste or develop some other code elsewhere, and then just type it right there. So in this case, it's a view model, and then it downloads these README files from internet, and then download it using URL sessions, and we inject that code by LLDB command, and then we could run that code by just typing this like expression view model download, and then save that result into these README variables, and then after a little while, because it's a synchronous task, and then we could retrigger that breakpoints and then see results by just typing poll. So we successfully inject that new code and modify control flow, and then without rebuild. Because and then if this result is correct, and then we can copy this injected code into the real function, and then compile it later, if we are satisfied with this result. So in summary, we have built the code inside this framework level to save build time from like more than 20 minutes and then into just several seconds. And then we preview and verify these logic implementations inside framework level. And then in the whole app level verifications, we could use code injections to modify control flow and the visual results without rebuild. So just only need to build once of the whole app. And then the final recap is to reduce the number of times to rebuild the whole app. Okay, thank you. ありがとうございました。